Hi folks, and welcome to Maths and Physics for You. Today I am going to simplify to you how to plot graphs using logarithmic scales, not linear scales. This is the difference. Logarithmic scales are very important and they have so many applications in engineering. So we'll simplify with an example. Alright, the difference between linear and logarithmic, briefly. Linear means the distance between units are the same, are equal. Like here on the x-axis, as you can see in this diagram, on the x-axis it's a linear scale. That is, the distance 0 to 1, 2, 3, the same. And if you want to have a value in between, like 0.5, it's halfway. And if it is 3/4, as you know, as simple as that. This is the scale, linear scale. Alright? That's the case. But in logarithmic scales, it's not like that. Alright? Yeah, we use powers. Okay, so this is how we do it to make it simplified. On the y-axis, in the blue color here on the right, we put the power, like here. See, this is called the power or index. In this example, we have y equal 3 times 5 to the power 2x. So this represents, this is the power, the one on top of this number 5, all right, which is going to be the base for the logarithm. All right. So in this, we put 1, 2, 3, 4, 5, 0, and the powers can be negative, no problem. So negative 1, negative 2, this we put them like in linear scales. They are also equidistant. That is the distance here, 0 to 1 to 2 to 3 to 4 to 5. They are the same distance. They are the same distance. But this is the main thing, that these values, the values here, they are not proportional. Okay, so 1 here is not the same like 1 between 1 and 2, the actual values. So we have actual values. I wrote them on this side, on the left side. The actual values of y. This is y. The actual value of y. This is the power of the base, 5. Okay? So these values, like from 0 to 1 in this equation, when the power is 0, the actual value is 5 to the power 0. Okay? 5 to the power 0 equals 1. Right? When x is 1, and when we have 1 here on the vertical scale, when the power is 1, this is not x equal 1, it's the power is 1, then the actual value is 5 to the power 1. Actual value is 5 to the power 1, which is 5. See? So this is 1, this is 5. But this is not 10. So it's not a linear. This is 5 to the power 2. That is 5 squared, which is 25. See, as if from here to here 5, then as if multiplied by 5. We have a base of 5. So it's like 25. The next one is like we multiply again by 5. So 125, which corresponds to the power of 3. 5, 3. The same thing, it keeps going. This is 4. 5, 4. 6, 25. See, the ratios here, the same ratios by 5. Proportional. So there is a ratio. When we have a scale, logarithmic scale, we talk about the ratios. Okay, between this one, 5 to 1 is 5. 25 to 5 is 5, and so on. All right. So with this in mind, let's see how we're going to solve and plot this function, this exponential function, y equals 3 times 5 to the power 2x. Okay, so we need to find the powers, like when x equal to 0 for this equation, where is the actual value here? Where is the actual value? We need to find out where is the actual value. As we expect, see from normally, if x is 0, you put here 0, so this will be 3 times 5 to the power 0. 5 to the power 0 is 1, so y is 3. So this is our expectation, it's going to be 3 if we solve it the usual way. Okay, we know the value. But what is the power here? All right, using the power on this graph. Okay, to do that, we use simple mathematics, simple equation, simplifying. But before that, let's look at the basic. Like if you have log of 100 base 10, 100 is 10 squared. That will be equal to 2. That is the power of 10. Same basis. Okay, so the power of the actual number, actual value of y, as if this is y. This is y. 100 is y. So to find the power, we say log of y in this equation. Now, we are not talking about log 10. So this is log 10 is just as an example to remind you of the relation. Okay. So to find the power on the vertical axis, here, that is how we have here 0, 1, 2, 3. These are the powers. Okay, so we say log y, the actual equation, base 5 will give you the power. The same thing, like this is the actual log y gives you the power. So this is comparison. Okay, in this case, we substitute for y 3 times 5 to the power 2x. If you have another example, that's all you have to put. All right? So, as you know from logarithmic rules, this will give you, this is the product. So it gives you a sum. It becomes log 3, 5, base 5, plus log 5 to the power 2x, 5. And 2x here comes in front. We keep simplifying. But log 5, 5 is 1. What is log 5, 5? 1. All right? So that then this equation gives us the power. Power on vertical line. Power equals to 2x, we put it at the beginning, plus log 3, 5. This is equation can help you to find the power on the vertical line. And after finding the power, we put to find the actual value. All we have to do is write 5 to that power. That will give you actual value and actual point to plot the straight line. All right. So this is the equation. Let's see how we now apply it so that we can graph this equation as a straight line now. Okay, so as we see, when x equal to 0 in this equation, x equal to 0, that goes 0. What we are left with, log 3 base 5. Now log 3 base 5, all you have to do is use your calculator, and it will give you the value of log 3 base 5. Okay, on this equation here, it will be 0.6826. So this value is the power on the x, the vertical line. So it's here. See, this is 0.6826. It's between 0 and 1. Right? So when x equal to 0, the power is 0.6826. But what's the actual value of the graph, our graph here? What's the value of y? Okay, we also need to know that using that. So it's as you know, we put 5 to the power of this value. The same thing here. We have 5 to the power 0 gives us 1 at this point. 5 to the power 1 gives you 5, the actual value. Now, for this equation, the power is this one at this point. 5 to the power 0.68, and that gives you 3. This is the actual value of 3. And we know that this is true by checking in the original equation, the normal way. If you put x equal to 0, this becomes the whole thing is 1. 5 to the power 0, 1. So 3 times 1, 3. So they are the same, give you the same value. They agree. Alright, so that's what we have here, as expected. Y equals 3 times 5 to the power 0 equals 3. So that's, then we get the first point in the graph. So what we get the first point on the graph. So this is the first point. That corresponds to x equals 0. The power 0.6826, and its actual value is 3. Actual value of y. Okay, from there? Okay, we need the second point that corresponds to x equals 1. That corresponds to x equals 1. We follow the same procedure by substituting in equation 2 to find the corresponding power. So we'll have 2 times 1, because x is 1, and we have written it here, similarly sub x equal 1 and 2. So power equal 2 times 1, because x is 1, plus log 3.5. So it's 2 plus 0.6826, the same thing what we got today. So this is constant. And this is like the y-intercept anyway. Alright, for the power function. Okay, as if this is a straight line. Power is a straight line, so it should give you a straight line. Okay, so that will give you 2 times 1, 2.68. So every time, this is 0.628, you go to 2. This is the 2, we're talking about powers. Between 2 and 3, 2.68. You see here, you notice that these distances are the same because of the, as we said before, of ratios. All right? Yeah. Okay, so this will be 2.68. And the value for that, 5 to the power 268, actual value is 75. And again, this is confirmed by putting here 1. So 5 squared times 3 is 75. All right, as we have written it here also, we can read it and follow. For x equals 1. Okay, so that gives us the second point. X equals 1, so you get that point. Okay, now the same thing, same exercise you do with x equals 2. As many points as you like. With x equals 2, you find the corresponding power. 2 times 2, 4, plus this one is going the speed, the same thing, 0.68. So it's 4 plus 0.682, 6, and it will give you 4.6826. We have it. All right, here it's done again. So 1x equals to 2, subbing there, we get the value, 4.682. Yeah. And the actual value is 5 to the power 4.6826, and it will give you 1875. And we plot it here. So, and the power, that's 4.68, and goes like that. And x equals 2 goes up. So this is the other point. And its actual value, as we see, 1875. Confirming that by checking the equation 1, 3 times 5, 2 times 2, 4. That will give you again 1875. And this confirms it. So there we go. So that will give you the straight line. So this is how you plot the straight line using the logarithmic scales. All right, and you can find any point, any actual point on it. And there you have it, folks. You can do more exercises, you can do more practice. And if you have any question, please ask. Please like and subscribe, and see you in the next video. See ya.